Okay, so you probably looked at this data. Now, the first question I would ask you, does this data actually make sense? And hopefully most of you would probably argue the answer is yes, because it looks like there was some impact of alcohol, it looks like there was some impact of pills, and it looks like there's definitely some sort of mix that when you combine pills and alcohol, performance is degraded. So this data makes some sense. We have 12 subjects here. It's called a 2x2 design. It's independent samples here, so it's a 2x2 design. Now, the next thing we move on to are what we can look at just by kind of eyeballing things. When you do a 2x2, or you have any situation where you have two independent variables, there are three effects you can look for. So when you do a two-factor ANOVA, there are three basic effects you can look for, and this is all in the book chapters as well, but hopefully you're following with me here. The first question, if you look down at Roman numeral 2, is there a main effect of alcohol? So it's called a main effect. That's given a special name. So to figure out, just in terms of looking at it, is there a main effect of alcohol, what you have to do is you have to look at the two levels of that variable. So what are the levels of alcohol? Hopefully you said no alcohol and 72 ounces of alcohol. So you have to look at what we call the marginal means. You see the letters MM? That's not because I wanted an MM right now, although I certainly could go for some M&Ms right now, MMs. Right now, boy, that was a bad joke. So the idea is you look at the means for that. So do you see where I got the number of 90 from? The idea is you look at the mean for no alcohol and you average across the other variable, the variable of Xanax. So if you take the mean of no alcohol, which is what, in no Xanax, 100, and then you get the mean of no alcohol and 10 milligrams of Xanax, that mean is 80. The marginal mean for that comes out to be 90. So when people got no alcohol, for the main effect, the average score was 90. What about when people actually got alcohol? Well, once again, you average across the other variable, the Xanax, or the pills, and you can see that the mean was 72 ounces of alcohol and no Xanax was 80. The mean when you got the Xanax with the alcohol was 20. And so if you get the average of 80 and 20, that marginal mean is 50. So when you look for what's called a main effect, you have to look at the two levels, or the levels of that independent variable, in this case alcohol, and you have to average across the other variable. In this case, you're comparing a 90 to a 50. So the first question that one could ask here, is that difference significant? And in this case, you would hope it would be. Now, I'm not going to have you do all the computations, but it looks like that's a pretty big difference. You can think of this as a treatment effect. Does alcohol affect things? Well, it certainly looks like it does. 50 is very different than 90. That 40-point difference is probably significant. So when we eyeball this, now we still have to do the statistics, but when we eyeball this, it looks like there will be a significant main effect of alcohol, because it looks like the 90 is very different than the 50. So one issue we can look at, is there a main effect of alcohol? That says look at one level of the independent variable and average across the other variable. So the 90 versus 50 looks significant, but we'd actually have to do the computations to see. Next, let's actually look and see if we can eyeball, does it look like there's a main effect of pills? So think about that. What do you have to look across? A main effect of pills. Is there a difference between no pills and a small dose, 10 milligrams of Xanax? So now, instead of going up and down on the matrix, you go across. You have to say, well, what's the mean when people had no Xanax? Go across alcohol, average 180, so you get 90 again, and then do the same thing, 10 milligrams of Xanax, average across no alcohol, 80, and having the alcohol, 20. So once again, it's a 90-50 mix there. Can you kind of see that going across? You can write in the margins 90 versus 50 as the marginal means there if you want. So do you think that difference is significant? Probably the case. 90 versus 50 is probably significant. So it looks like we may have two main effects here. It looks like there may be a main effect of alcohol. Taking alcohol decays performance, just in general. And then it also looks like taking Xanax also decays performance, just some. But then there's one final question that we have to look at as well, and this is perhaps the most important question. Is there a statistical interaction between the alcohols and pills? Is there a statistical interaction between the alcohol and pills? The reason I chose this example is because alcohol and benzodiazepines, there's actually a term we frequently use when we mix these things. Have you heard the term drug interaction before? What does that term mean, a drug interaction? A drug interaction means that if you mix one chemical with another chemical, that the combination of these two products is potentially very dangerous to the human body. And that's exactly what's going on here. We actually know that alcohol and barbiturates, actually in this case benzodiazepines, they actually work on the same receptors in the brain. Now, of course, that's a physiological psychology issue, but they work on the same receptors in the brain. And so one thing that we know, even if you think about the case like Marilyn Monroe, is that if you combine alcohol and Xanax together, that the combination of these two together is potentially very, very deadly. So that's kind of what we're focused on here. And in order to see if there's what we call a statistical interaction, what you actually have to do is you have to make a little picture like I've done down in C. A picture. Now, if you look at that picture, you can see the top line that's kind of going across. It goes from 100 to about 80. So that represents the no Xanax group. So if you don't have Xanax and you have alcohol, you go down by about how much? 20. Now let's look at what happens if you have Xanax in you. If you have Xanax in you, you start off with an 80, but what happens when you add the alcohol? You go all the way down to a 20. So if the lines are very non-parallel, that means you probably have a statistical interaction. And in this case, that's probably going to be significant because the lines are so non-parallel. When you combine the alcohol with the pills, it is so unique that it causes an interaction. And let me share a little bit more with you if you can follow the idea here. If I asked you, generally speaking, what was the impact of alcohol alone on performance? Well, if you look at it, the impact of alcohol alone on performance, when they have no alcohol, it was 100. When you had alcohol, it went down to about 80. So in general, alcohol alone caused a decrement of how much? 20. What about when you had just some pills alone? When you had no alcohol and then you added the pills alone? Well, same thing. There was kind of a 20-point effect. When you had nothing in your system, it was 100. If you put 10 milligrams of Xanax in, the mean was 80. So when you just had Xanax in, you went down by about 20. When you just had alcohol in, you went by about 20. So what would you predict if there wasn't an interaction? Well, what you would predict is that the 20 and the 20 would kind of add up, and the mean for that 10 milligrams of Xanax and 72 ounces of alcohol should be about 60. But in fact, that isn't what happened. And in this case, the mean is 20. If the mean was 60, the lines would be parallel, and you'd have no interaction. In this case, when you combine alcohol and pills together, you can't just add them up. It's in fact not an additive function. It's what we call, I hate to say the word, multiplicative. Multiplicative means you have to multiply things, and that's called a statistical interaction. So if the lines are very non-parallel, you can be pretty sure there's an interaction. And the fact that you have that group that got the alcohol and the pills together and their mean is down at 20, and if you look at that graph, that suggests there's probably a statistical interaction here. So in summary then, when we do a two-factor ANOVA, we have to look for three basic statistical findings. Is there a main effect of one variable, alcohol? To eyeball that, you look at that variable. What are the two levels of alcohol? 0 and 72. You get the marginal means. You say, well, that's a pretty big difference. It's probably significant. Then you do the stats. Then the second question you ask, is there a main effect of the other variable, pills? You go the other way across the matrix, 90 and 50 again, probably significant. And then third and most importantly, is there something unique about combining alcohol and pills here? If you make a graph out and the lines are very non-parallel, there's a good chance that there is a statistical interaction. Hopefully this makes sense for you, and that will conclude number 2.